equations. Mine is going to start on page 6. On page 6, my title is Solving Systems of Linear Equations. We have one vocabulary word that we're going to learn today, and that is, what is a system of equations? That is when two lines touch when graphed on the same coordinate plane. If they touch, the points at which they touch are the solution or the solutions known as x or y. So we're looking at the location where those lines meet or touch. So here is the first example that you're going to get and put into your notebook. We have the red line and the blue line. If I was to take them together and put them on the same graph, they would touch at this point, which I would label the x value and the y value. And I would replace these with numerical numbers. So now we're going to do a little exploration. I want you to think about how many ways you can get straight lines to cross using your arms. Pause the video at this time and use your arms and see how many times they cross. The first scenario, we know that we can definitely have our arms never touching. If we graph two parallel lines that do not cross, then we say the system has no solutions. So if my lines are parallel, that means they are never going to cross, so we will have no solutions. Scenario 2 is if our arms cross at only one point. We graph the two lines and they cross exactly at one point, then we say the system has one solution. And that solution is point x, y. Again, we would know what that value was based off of the x and y value in our equation. On our graph. The last scenario is what happens if when we cross our arms, they are on top of one another. This system means that they have infinitely many solutions. That means that all of the points are solutions, because every value of x and y is going to be the same for both lines. Okay, now we're going to go ahead and we're going to do some practice. Okay, so at the top of your paper, I have printed this for you, so go ahead and glue that in. And then we're going to use the graphs to determine the systems, whether they have none, one, or infinitely many solutions. So the first one we're going to take a look at is, we're going to ignore this one over here for right now, is y equals negative x minus 3 and y equals x minus 1. Remember from the last set of notes that our m in this case is negative 1 and our b is negative 3. So we're going to start at negative 3 and we're going to use our slope of negative 1 over 1. So I'm going to go down 1 to the right one, down 1 to the right one, and I'm going to do that creating a line that I can connect, and I'm going to extend it in both directions. I'm going to do the same thing with my pink. My m is 1 over 1 and my b is negative 1. So this time I'm going to come down to negative 1 on the y-axis. That's my y-intercept. This time I'm going to go up 1 over 1. Up 1 over 1. If I wanted to, I could also come down 1 and left 1. And when I do that, notice that the pink line and the blue line now cross. They intersect at a point which means this particular problem has one solution, and it is located at -1, -2. We're going to take a look at another example over here. Y equals -x minus 3, and a new equation, y equals -x plus 2. So we're going to graph. Remember that our slope is -1/1, and our y-intercept is -3. So we're just regraphing the blue line that we had from over here. Down 1 to the right 1. This time I'm going to go up and to the left. That's also a possibility when graphing our lines. So I'm going to connect my points. And the next one, my slope is -1/1. My y-intercept is 2. So I'm going to come up to the +2. I'm going to come down 1, right 1, down 1, right 1. Interesting. It doesn't seem like these two lines are ever going to cross, and that's because there is no solution. These lines are parallel to one another. They are never going to cross and have any kind of point in contact. Our last example is just a little bit different. This example is where I have one equation that's not in slope-intercept form and one equation that is. Well, we know that in order for us to graph this, it needs to be in y equals mx plus b. So I'm going to do a little bit of manipulation here. I'm going to take 2x plus 2y equals -6. And I'm going to change it so that it's in the form of y equals mx plus b. 2y equals -2x minus 6. Now I'm going to divide everything by the 2. And so we have y equals -x, because 2 divided by 2 is 1, minus 3. So now I have my two equations. I have one here, and I have this one down here that I need to graph. So this m is -1/1, and the b is -3. This m, is -1/1, and the b is -3. Hopefully you notice that these are the same values. So we're going to see what happens when we graph them. I'm going to start with my pink. So I'm going to come down to the -3, -1/1. I'm going to graph my pink line. Oops. Okay, now we're going to do the same thing with our blue. We start at -3, down 1 to the right 1. Hopefully you notice that I'm plotting the same points, which means that these graphs are identical. So this has, let me write it in red. Infinitely many solutions. That means that these equations are actually the same, although they look different when we started. They ended up being the same equation when we put them into slope-intercept form. Go ahead and pick up your practice problems and begin practicing.